In this lesson, let us see an example of three planes makes a no solution category. Okay, consider the three plane equations. Pi1 is x minus 2y minus z equal to minus 1. Pi2 is 2x plus y plus 3z equal to 13. And the third plane is x plus 8y plus 9z equal to 5. Okay, in the previous video, I explained in the last row, the third term, if h becomes 0 and the I is not equal to 0, please refer the previous video which I explained the definition for this. Then you will get 0x plus 0y plus 0z equal to 5. Say I is not equal to 0, say I equal to 5. Then you will get 0 equal to 5, which is not true. So then we conclude that this system of the simultaneous equations are inconsistent. Then we can conclude that no solution exists. Okay, that's what we are going to do. We'll do the row reduction method here. First, let's make the augmented matrix. The coefficient matrix is 1, minus 2, minus 1. This is Z. And the right hand side, we have minus 1. 2, 1, 3, 13, 1, 8, 9, and 15. Okay. Our main aim is to make this term, and this term. To make it what? 0. So you need to make this 0. That's what our the main aim in this row reduction method. Okay. So this is 2. Second row first term is 2, and the first row first term is 1. So you can multiply the first row by 2 and subtract with second row. You can easily make it as 0. And third row, you can see this is 1 and this number also 1. Just subtract third row and first row, you can make the first term 0, and hence we get the other terms. So I'll write the first row as it is: 1, minus 2, minus 1, and minus 1. The rule for the second row is the new R2 is R2 minus 2 times of R1. Okay, so 2 minus 2 times of 1 will make it as 0. Next, coming to the second term, 1, R2 is 1, R2 minus 2 times of the corresponding term from the first row, that is minus 2. 1 plus 4 makes 5. Right? Now coming to the next term, 3 minus 2 times of the corresponding term. 2 times of the corresponding term is minus 1. 3 plus 2 makes 5. So this term also will become 5. Coming to the last term in the second row, R2, which is 13, minus 2 times of the corresponding term is minus 1, which makes 13 plus 2 is 15. All right. So we're done with the second row. Let's move on to third row. The new R3 is R3 minus R1. Just subtract because both are 1, 1. It's easy to make it R3 minus R1. Subtract 1 minus 1, 0. 8 minus of minus 2 makes 8 plus 2 makes it as 10. 9 minus of minus 1 is 10 again. 15 minus of minus 1. Is it? I think when I write here, it is not 15, it is 5. Right? Sorry. This is 5. 5 minus of minus 1 makes it as 6. Fine. I guess no errors in this. All right. Now, if you compare uh, the second and third rows, here you can see 5, 5, 15, 10, 10, 6. Okay, we made these two numbers 0. Next, our aim is to make this number 0. Okay, what we can do, this is 10, and as I said in my previous video, you have to use second row and third row only to make this is 0. If you use first row, then again it will become non-zero number, right? Now write the first two rows as it is. 1, minus 2, minus 1, minus 1, 0, 5, 5, 15. What we can do, the new R3 is 10 minus 2 times of 5 makes it as 10, right? So R3 minus 2 times of R2 can make the second term 0 in the third row. Fine. So here both the numbers are 0, so this will be 0. 10 minus 2 times of 5 will make it as 0. Again here you see 10 and 5 only. So 10 minus 2 times of 5, again it will make it as 0. And coming to the last term, 6 minus 2 times of 15. Okay, 6 minus 30, this will make it as minus 24. I'm getting? So as I said in the beginning, if H is 0 from that augmented matrix after row reduction, after getting the triangle zeros, here this is H and this is equal to 0, and this I equal to negative 24 we got, which is not equal to 0. So the last row says that 0x plus 0y plus 0z equal to minus 24. Okay, since all these coefficients are zeros, so you'll get 0 equal to minus 24, which is not true. So then we can conclude that the system of linear equation, the simultaneous linear equations what we got here, all inconsistent. Okay, hence no solution exists. In the previous video, we've seen an example of unique solution, how to solve row reduction method to get unique solution. And in this example, you've seen how an inconsistent equation, system of equations gives no solutions. So you can say that these three planes doesn't make any solution. Fine. In the next video, let us see how like the infinitely many, how to solve an infinitely many solution uh, planes. Thanks for watching.